Section 1.1, lines in the plane. Some important terms that you will need to know throughout this chapter. First of all, starting with the different forms of the equation of a line. Slope-intercept form is y equals mx plus b. That is the form you will use most often if you are asked to graph a line. Just as the name suggests, when we have an equation in slope-intercept form, we can easily identify the slope and the y-intercept. Point-slope form. Y minus y1 equals m times x minus x1. Just as its name suggests, point-slope form is the form that you will use to write the equation of a line if you are given a point and the slope of the line. General form is just a form that you can manipulate your equation to be represented in this form, ax plus by plus c equals 0, where a, b, and c have to be integers, so we do not have any fractions. We do not have any decimals when we are talking about general form. And the first term, your x term, has to be positive. Those are the conditions that must be satisfied for it to be in general form. Formula for slope. Remember, slope in our two equations up here at the top is represented by the variable m. Slope is rise over run, which is the difference in the x variables, divided by the difference in the x variables. Now, most of you can remember that slope is rise over run, so we should not have students getting mixed up with what goes on top here, the x's or the y's. If you think about the coordinate plane and you rise in the coordinate plane, you would be moving along the y-axis, which is why the y's are on top. If you think about running in the coordinate plane horizontally, those are across the x-axis. That's why the x's are down here in the bottom. You will have to be able to express your equations in all three of these forms. If the directions do not specifically tell you what form to use, then you are always going to use slope-intercept form. If they do tell you what to use, then obviously put it in the form that you're asked for. But if it doesn't specifically say use point-slope form or general form, then your final equation should always be given in slope-intercept form. First example here, finding slope. Plug into your slope formula. Difference in y's, -7 minus 3, over difference in x's. Now, it does not matter what order we subtract y's. So I could have went -7 minus 3, or I could have done 3 minus a -7. But whatever order you subtract the y's in, you must also subtract the x's in that same order. So because I chose to go -7 minus 3, now I have to go 3 minus a -4. Simplify that. Up top, we get -10. In the bottom, 3 plus 4 is 7. There's our slope. Remember a couple things about slope. When it is negative, as it is here, that line will be going downhill as we look from left to right. If the slope is positive, that slope will be going uphill. Letter B. Again, just plug into your slope formula. Difference in y's, difference in x's. We get 0 over 8, which is just a slope of 0. When we have 0 slope, remember what that tells us. If a line has 0 slope, we are talking about a horizontal line. And remember, horizontal lines are always in the form of y equals some constant. Letter C, again plug into your slope formula. Difference in y's over difference in x's. We we get negative 12 divided by 0. Anything divided by 0, remember, is undefined. So we have an undefined slope here. And remember, when we have an undefined slope, that it is the graph of a vertical line. And remember, all vertical lines are of the form x equals some constant. Write the equation of the line passing through the point negative 6, 2, and having a slope of 4. Here we are given a point and a slope. That means you should be using point slope form. So y minus y1 equals m times x minus x1. Plug in. The point on the line is what we plug in for x1 and y1. So I'm going to put in negative 6 for x1. I'm going to put in 2 for y1. And I know the slope is 4. I'm going to put that in for m. So we have y minus 2 equals 4 times x plus 6. Now, if this said write the equation in point slope form, you would be done. This right here is point slope form. This does not give us a specific form to put it in, so we need to continue. And remember, we want to put it in slope-intercept form since it does not tell us a form to put it in. To go from point slope form to slope-intercept form, there are always 2 steps. First step is distribute the slope through. We get 4x plus 24. Last step, finish getting y by itself by adding or subtracting the constant over. We end up with y equals 4x plus 26. That form right there is slope-intercept form. And for this problem, we would be done because it does not tell us what form to put it in. If it doesn't tell us what form to put it in, we're going to leave it in slope-intercept form. I'm going to go one step further and put it into general form just so you can see how easy it is to get an equation to general form once it's in slope-intercept form. Simply move the y term over. We end up with 4x minus y plus 26 equals 0. Notice there are no fractions. There are no decimals. The x term is positive, so we've satisfied the conditions for general form. All right, next one here. Now getting into graphing. Graph each line. Y equals 2/3 x plus 1. What method you use for graphing at this point, I do not care. I think it's easiest to graph out of slope-intercept form and identify the slope and the y-intercept. If you want to do it by making an xy chart, go ahead and do that. It's up to you what form you use. I'm going to do it from slope-intercept form. We know that our slope is 2/3. Y-intercept is the ordered pair 0, 1. So from here, I'm going to put a point on the y-intercept at 0, 1. And I'm going to use our slope. Now, rise over run. From there, I go up 2 and over 3. Up 2 and over 3. Connect those points with a line. And there's our graph. Letter B, y equals negative 2x minus 1. This time our slope is negative 2. And our y-intercept is the ordered pair 0, negative 1. There's our y-intercept. Slope of negative 2, rise over run. Remember, an integer can be written as a fraction by simply putting it over 1. So this is down 2 and over 1. Down 2 and over 1, and so on. Connect those points, and there's our line y equals negative 2x minus 1. Notice with the negative slope, we were going downhill with our graph. With our positive slope here, we were going uphill as we look at the graph from left to right. 2 other terms we're going to talk about: parallel lines Remember our lines that never intersect, and what guarantees that they never intersect is they're lines that have the same slopes. Perpendicular lines are lines that intersect to form four right angles, and the algebraic property that guarantees that they are going to be perpendicular is the lines have opposite reciprocal slopes. So looking at problem 4 here. Find the equation of the lines parallel and perpendicular to the line 2x plus 3y equals 1 and passes through the point 1, negative 3. Write each equation in slope-intercept form and general form. Well, first thing we need to know if we are going to write the equation of a line parallel or perpendicular, we need to know the slope of our original line. So this line here, 2x plus 3y equals 1, we need to take this equation and identify the slope. To do that, we need to get it into slope-intercept form so we can identify the slope, which means we solve for y. Y equals negative 2/3 x plus 1/3. So once we have that in slope-intercept form, we can identify the slope of this line. Slope is negative 2/3, which means the slope of any line parallel to this line has to be exactly the same, negative 2/3. And the slope of any line perpendicular to this line has to be the opposite reciprocal slope, positive 3/2. Now that I have that information, we can go ahead and find both the line parallel and perpendicular passing through that point. Let's start with the line parallel. Again, I'm going to start with point slope form since we now know the slope. Here's the slope we're going to use for a parallel line. Here's the point right here that we're going to use. Point slope form, y minus y1 equals m times x minus x1. Go ahead and plug in. We get y plus 3 equals, our slope that we're using is negative 2/3 times x minus 1. Subtract the 3 over. 2/3 minus 3 is negative 7/3. There's our equation in slope-intercept form. Now we were also asked to express that in general form. General form, remember we want the x term to be positive, so this time I'm going to move both of these terms over to the left side with y. We get 2/3 x plus y plus 7/3 equals 0. From here then, to finish general form, we also cannot have any fractions, so I'm going to multiply everything in here by 3. We get 2x plus 3y plus 7 equals 0, and there is general form. Line now perpendicular. Our line perpendicular, we're going to do everything exactly the same way, only now this slope right here, instead of being negative 2/3, is going to be positive 3/2. So I can basically take this equation right here, y plus 3, equals, change the slope to 3/2 now that we want a line perpendicular, and leave everything else the same. Distribute the slope through. Subtract the 3 over. Y equals 3/2 x. We need to take negative 3/2 minus 3 is negative 9/2. There is slope-intercept form. We also want to express this in general form. Since the x term is already positive over here, this time I'm going to subtract the y over to the other side. 3/2 x minus y minus 9/2 equals 0. And this time, to clear out the fractions, I need to multiply everything by 2. And we get 3x minus 2y minus 9 equals 0. Last one here, number 5. Company purchases a machine for $20,000. In 4 years, the machine is worth $10,000. Write a linear equation that gives the value V of the machine after T years. All right, when we go to write our equation here, the first thing you need to do is recognize that we don't have variables X and Y like we normally do. Okay, normally we deal with everything in terms of X and Y. That's why we have Y equals MX plus B and so on. In this case, we have different variables. So decide what X and what Y is going to represent in the terms of this equation. X will always be our time. Y in this case is V for the value of the machine. So our ordered pairs here, instead of being X and Y, would be T and V, time and value of the machine. So what ordered pairs are we given here? We're given that a company purchases a machine for $20,000. In 4 years, the machine is worth $10,000. Well, there's two ordered pairs in those two sentences. First one, 4 years. Time of 4 years, it is worth $10,000. Second one, a company purchases the machine for $20,000. So if it just initially purchases it, and T is the value after T years, that means that no time has passed when they initially purchase it, when it is worth $20,000. No matter what form we use, we always need to know the slope of a line. So let's go ahead and find the slope. Difference in Y's over difference in X's. Plug that in to your calculator. Simplify, we get negative $2,500. Why is that slope negative? Because the value of the machine is decreasing each year. So now I know the slope. This ordered pair that we're given here was a special ordered pair because X is 0. If X is 0, we know that is the y-intercept. So normally I would go to point slope form here. Don't need to because we know the slope and we know the y-intercept. So go to slope intercept form. Y equals negative 2,500 T, and actually I should be using the variable V here, so we're talking about the value, plus 20,000. There is our final equation.